Hello class. In this video, we're going to continue where we left off in section 2.5. I'm going to try to solve linear inequalities in one variable. So they give us a definition here. Some of the properties here. It says if A, B, and C are real numbers, we have the following properties of inequalities. So if I know A is less than B, and I add C to both sides of this inequality, the inequality is still true. Right? If A is less than B, well, A plus C will still be less than B plus C, right? And it also works for multiplication, right? As long as C is not 0, right? So if A is less than B, well, then AC and BC will be less than, AC will be less than BC, just like A was less than B, okay? But notice they do use the word here, positive number. So the value for C has to be positive when we multiply both sides. Otherwise, we're going to have to do something with the inequality sign. So to verify, right, if I know 2 is less than 6, right, I'm saying 2 is less than 6. If I add 5 to both sides, so basically I'm saying my value for C is 5. I'm adding 5 to both sides of this inequality. It doesn't change the result. The result is still true, right? If 2 is less than 6, 2 plus 5 will be less than 6 plus 5. Right? And it works for subtraction too, right? If I know 2 is less than 6 and I take away 5 from both sides, this inequality is still true, right? Negative 3 is still less than 1, okay? For multiplication, right? If I know 2 is less than 6 and now I multiply 2 by 5 and I multiply 6 by 5, 10 is still less than 30, so the equation is still true, right? And you can see it works for division as well. So, the only thing that changes is when we multiply or divide by a negative number, okay? So if I have 2 is less than 6 and I multiply by a negative 5, now I have negative 10 is less than negative 30. That's not true, right? Negative 30 is less than negative 10. So you have to change the inequality sign. It has to point the other way, okay? So when we multiply or divide, we have to change the direction of the inequality sign. Right? Only when we multiply and divide by a negative number. So let's take a look at a couple of these problems. We'll kind of work them out. Okay, let me get my pen. Okay, so I wrote letter A over here. And to solve this, we would subtract 3 from both sides. And I'm going to be left with x is greater than negative 8. And that's it for letter A. Right? If I rewrite letter B up here, you get something that looks like this, right, up here. So to solve this problem, I'm going to divide both sides by 5, and I would be left with x is less than or equal to negative 3. I'm just going to put a circle around that. Right, I'll circle. This is my answer. All right, so I didn't have to change the inequality, the direction, because I divided by positive 5. If I had to divide by a negative 5, I'd have to change the direction of the inequality sign. Let's look at something like letter D. So I've rewritten letter D, and first thing I'm going to do is subtract 3 from both sides. So you see I'm left with negative 2x is greater than or equal to negative 26. And let's kind of continue with the rewrite. So to finish the problem, I have to divide both sides by negative 2. So this is the time where, since I'm dividing by a negative, I have to change the direction of the inequality sign. So see how it's pointing to the right? I have to change that and make it point to the left to complete the problem. And I only flip the direction of the inequality sign because I divided by a negative. Okay? We'll practice a few more problems in the next page. Actually, before we go to the next page, I do realize that the instructions say, and graph the solution set, right? So I only solved the problems. I didn't graph these 3. So let me add the graph real quick. Okay, so for the first letter, letter A, right? Our answer was this x is greater than negative 8. And it's an open circle, because it's not less than or equal to. So I draw an open circle around negative 8, and x is actually greater than negative 8, so I draw an arrow going in that direction. Right? For letter B, the final answer was x is less than or equal to -3. So I'm going to draw a closed dot here at -3, and x is smaller, so we go to the left. For letter D, the final answer was x is less than 13, less than or equal to. So it's a closed dot at 13, and then we draw an arrow to the left to indicate less than. Okay, so now I've solved the problems and I actually graphed the solution set. Now let's go to the next page. I actually went over 2 pages where there's some practice problems. So let's try a few of these problems. I'm going to start with number 12, right? So I'll rewrite number 12 up here. 8 minus x is less than 1. So I'm going to subtract 8 from both sides, and I'm left with -x is less than -7. And to get rid of the negative in front of an x, divide both sides by -1. But when you divide by negative, you have to change the direction of the inequality. All right, see how I flipped the inequality sign? It went from pointing left to pointing right. So this is our final answer, right? X is greater than 7. And if I want to graph this, right, you could say 7, 8, 9, 6. So x is greater than 7. That's an open circle, and it goes to the right. That's my graphical solution. This is my symbolic solution. That's number 12 done. So I'm going to erase this and do number 13. So if you want to take a moment to copy this down, feel free to do so. Now I realize I did not graph the solution set, right? Because I solved the problem. I solved number 13, but I have to graph it. So x is greater than or equal to -9 would look something like this. Maybe you do -10, -9, -8, and so on. It's an open circle at -9, and x is bigger. There's my graphical solution. Okay? Now, if I want to do number 15, I'm going to distribute the 4. So I'm left with 9x plus 18 is less than or equal to 8x minus 12. And now I will subtract 18 from both sides. And I'm left with 9x is less than or equal to 8x minus 30. And then if we subtract 8x from both sides, you'll see we're left with x is less than or equal to -30. All right, that's my answer. Now, to graph it, I'll just do a freehand version here. We'll call this -32, -31, -30, -29. I think you get the picture. And we need a closed dot at 30, and x is less than that. That's my graph. Okay, it doesn't have to be a Picasso, but it does convey the correct solution. Okay, so that's it for section 2.5. I'd really like you to go to the next page and take a look at the summary and try to work through these problems. The answers to the summary are in the back of the book. The answers to the problems, practice problems, are also in the back of the book. Please feel free to bring your questions to my Zoom office hours. Thank you for watching.